Maybe try the makeup counter at Walmart instead, laughed Derek Mason as he watched Lisa Chen struggle with the steel beam that weighed more than she did. At 28, Lisa was the smallest person on the Morrison construction crew, and every morning brought fresh reminders of her physical limitations. The other workers saw a woman who barely cleared 5 feet, trying to compete in a man's world. They didn't see the MIT-trained structural engineer who understood load-bearing physics better than anyone on the site. And they had no idea that in exactly 3 hours, when 50 tons of concrete would come crashing down, Lisa's weakness would become the strength that saved 12 lives. Lisa Chen had been working at Morrison Construction for 6 months, hired as an administrative assistant, despite holding 3 engineering degrees and a specialization in structural dynamics that had taken her 7 years to complete. Her grandfather, Chen Wei, had built half of downtown with Morrison Construction 40 years earlier, and the company had hired her as a favor to his memory. What they hadn't bothered to read was her actual resume. Chen barked foreman Brad Stevens from across the construction site. "Coffee's getting cold in the trailer. That's more your speed anyway." Lisa nodded silently and made her way to the trailer, ignoring the chuckles from workers who saw her as nothing more than an office girl playing dress-up in a hard hat. But as she walked, her trained eyes automatically assessed the crane positioning, the concrete pour schedule, and the load distribution calculations posted on the project board. Something was wrong, very wrong. The crane was positioned 3.7 degrees off optimal angle for the concrete pour scheduled in 2 hours. The load distribution showed 47 tons being lifted to the 15th floor, but the structural support calculations were based on a 42-ton maximum load. The safety margin they thought they had didn't exist. Lisa pulled out her worn notebook, the same one her grandfather had used during his 40 years in construction, and began running calculations. The numbers painted a terrifying picture. System failure was not just possible, it was inevitable. She had to warn someone. But who would listen to the coffee girl? Stevens. She approached the foreman with her notebook in hand. "I think there might be an issue with the concrete pour calculations." Brad looked up from his clipboard with barely concealed irritation. "Chen, stick to making copies and scheduling meetings. Leave the engineering to people who actually understand construction." "But the load distribution is fine," Brad interrupted. "Designed by real engineers with real degrees from real schools." Lisa's jaw tightened. Her MIT diploma was framed and hanging in her apartment, but it might as well have been invisible for all the weight it carried here. As the morning progressed, Lisa watched the crane operators position the massive concrete bucket with growing anxiety. Every measurement confirmed her worst fears. They were about to attempt a pour that exceeded the building's current structural capacity by nearly 12%. "Hey, office girl," called out Danny Rodriguez, one of the crane operators. "Shouldn't you be inside filing paperwork instead of watching real men work?" Lisa forced a polite smile and moved closer to the control station. Danny, I was wondering if you could check the load specifications one more time. The concrete weight seems fine to me, Danny interrupted, not even glancing at his gauges. Been operating cranes for 15 years. I think I know what I'm doing. But Lisa could see what Danny couldn't, or wouldn't. The digital readout showed 47.3 tons, exactly as she'd calculated. The building's structural support, designed for a maximum of 42 tons at this stage of construction, was about to be tested beyond its limits. She tried a different approach. What if we delayed the pour for a few hours, just to double-check the... Lady, Derek Mason interrupted, wiping grease from his hands with obvious annoyance. We're already behind schedule because of weather delays last week. We're not stopping work because someone's nervous. Lisa pulled out her phone and quickly accessed the structural engineering database she'd helped design during her time at MIT. The building's stress analysis confirmed her fears. At 47 tons, the load would exceed the safety threshold by 11.9%. I have the actual engineering specifications right here, she said, showing her phone screen to Derek. The load-bearing calculations show... Derek barely glanced at the screen. Anyone can Google stuff and pretend they know engineering. We've got real engineers who already approved this pour. What Derek didn't know was that Lisa had written some of the safety protocols he was dismissing. Her graduate thesis on dynamic load distribution had been published in 3 engineering journals and was currently being used in construction projects across 12 states. Brad, Lisa approached the foreman one last time. I'm begging you, please just look at these calculations. The margin of error is... Chen, Brad's voice carried a warning edge. You're paid to answer phones and make coffee, not to question people who actually know what they're doing. Lisa watched in growing horror as the crane began its ascent, carrying 47 tons of concrete toward the 15th floor of a building that could safely support only 42. Her grandfather's voice echoed in her memory. In construction, Xiaoli, the building always tells the truth, but people don't always listen. She stepped back and began timing the operation. According to her calculations, they had approximately 17 minutes before the concrete reached critical height. At that point, the additional stress would create a cascade failure that would bring down 3 floors of the building. 12 workers were currently on those floors, completely unaware that their lives depended on calculations that no one would let her share. At 11:47 a.m., Lisa's worst predictions came true. The concrete bucket reached the 15th floor and began its pour. For the first 30 seconds, everything appeared normal. Then Lisa heard it. A sound that most people would miss, but that made her blood freeze. The subtle groaning of steel under excessive stress. "Stop the pour!" she shouted, running toward the crane operator. "You need to stop right now." Danny Rodriguez looked down at her with annoyance. "Lady, back off. You're going to cause an accident." But the accident was already happening. Lisa watched in horror as stress fractures appeared in the building's support columns, exactly where her calculations had predicted they would. The building was failing in real time, and no one else seemed to notice. "The support beams are buckling," she yelled, pointing upward. "Look at column C7. Derek Mason followed her gaze and saw what she was pointing at, a hairline crack running down the concrete support. His face went pale. "How did you—" "Because I'm a structural engineer," Lisa snapped, her patience finally breaking. "I have 3 degrees from MIT, and I've been trying to warn you for 2 hours." But there was no time for explanations. The crack in column C7 was spreading, and Lisa could hear the building's steel framework beginning to sing, the high-pitched vibration that meant catastrophic failure was imminent. "Everyone off the upper floors now," she commanded, her voice carrying an authority that made hardened construction workers stop and listen. "You have maybe 3 minutes before this whole section comes down." Brad Stevens finally grasped the severity of the situation. "How do we stop it?" Lisa was already running toward the crane controls, her mind racing through possible solutions. The concrete bucket still held approximately 15 tons, enough weight to complete the structural collapse if it remained suspended above the failing support system. "We need to redistribute the load immediately," she called out, reaching the crane operator's station. "Danny, lower the bucket to the 10th floor and spread the concrete across multiple support points." "That's not how concrete pours work," Danny protested. "We can't just—" "We can't pour it where it was planned," Lisa interrupted, taking control of the crane's manual override. "The building can't handle the concentrated load, but if we distribute it across 3 support columns instead of 1, we can prevent total collapse." Her hands moved across the crane controls with surprising expertise. This wasn't theory anymore. This was applied engineering under pressure, using every principle her grandfather had taught her and every calculation she'd perfected at MIT. "How do you know how to operate that?" Derek asked, watching in amazement as Lisa maneuvered the massive concrete bucket with surgical precision. "Because," Lisa replied, carefully positioning the bucket over a stronger section of the building, "my grandfather taught me to operate every piece of equipment on a construction site before I was 16, and because I designed crane safety protocols for the Boston Harbor project." The building's groaning began to subside as Lisa redistributed the concrete load across multiple support points, each one carefully calculated to handle the stress without exceeding safety limits. What should have been a catastrophic failure became a controlled engineering solution. Within 20 minutes, the crisis was over. The building was stable, the concrete was properly placed, and 12 workers who had been in mortal danger were safe. The silence that followed was unlike anything Lisa had experienced in 6 months at Morrison Construction. 12 workers who had been evacuated from the upper floors stood in a semicircle, staring at the woman they'd dismissed as just the coffee girl who had just saved their lives. Brad Stevens was the first to find his voice. You're telling me you're actually an engineer? Lisa wiped concrete dust from her hands, her grandfather's old notebook still clutched in her grip. Structural engineer, MIT class of 2018, specialized in dynamic load distribution and crisis intervention protocols. Derek Mason, who had spent months mocking her physical limitations, looked pale as he processed what had just happened. But why didn't you tell us? Why work as an administrative assistant? I tried to tell you, Lisa replied quietly. Every day for 6 months. But you saw my size and decided I couldn't possibly understand construction. She gestured toward the building that was still standing because of her intervention. My grandfather built half this city with Morrison construction. I wanted to follow in his footsteps, but apparently that required me to prove myself every single day. Danny Rodriguez approached hesitantly, his crane operator swagger completely gone. Lisa, we could have died up there, all of us. You would have, Lisa confirmed matter-of-factly. The structural failure would have brought down floors 12 through 15. The falling debris would have taken out floors 10 and 11 as well. Brad Stevens pulled out his phone and began scrolling through company records. Your file says administrative assistant, high school education, no relevant experience. Check again, Lisa suggested. Under emergency contact information, you'll find my MIT faculty advisor's number, Dr. Sarah Chen, head of structural engineering. She can verify my credentials. As Brad made the call, the other workers began approaching Lisa with a mixture of respect and shame. The woman they had spent months belittling had just demonstrated expertise that none of them possessed. Lisa, Derek said quietly, I owe you more than an apology. We all do. Lisa looked around at the faces that had shown her nothing but dismissal for 6 months. What I want, she said finally, is to do the job I was actually trained for. I want to use my grandfather's tools to build something safe and lasting, just like he did. Brad ended his phone call, his expression transformed. Dr. Chen confirms everything. She also mentioned that you designed the safety protocols we use for high-rise construction. Lisa nodded. Among other things. There's going to be a position opening up, Brad said carefully. Senior structural engineer. It pays 3 times what we've been paying you as an assistant. I'll consider it, Lisa replied, on one condition. Every safety concern raised by any worker, regardless of their position or appearance, gets proper review. No more dismissing people because they don't look the part. 6 months later, Lisa Chen stood in the site office of Morrison Construction's newest project, reviewing structural plans with a team that included 3 engineers she had personally recruited, all women who had been overlooked by other companies. Her grandfather's tools hung proudly on the wall behind her desk, and his notebook remained her constant companion. The building she had saved became known throughout the construction industry as the Chen intervention, a case study in why diverse perspectives and rigorous safety protocols mattered more than traditional assumptions about who belonged on a construction site. Sometimes the strongest person on the site isn't the one who can lift the most weight. Sometimes it's the one who can move mountains with their mind. Lisa's story reminds us that strength comes in many forms, and the quietest voice in the room might have the most important thing to say. If you were Lisa, would you have kept trying to warn them or given up? Let us know in the comments. If this story inspired you to listen to everyone, regardless of their size or appearance, smash that like button and subscribe for daily inspiring stories. Don't forget to share your thoughts below. We read every comment. Thanks for watching. See you in the next one.